Hold on, let me just make sure I'm in the right spot. There we go. Okay, so first off, before we even talk about how to find residuals, we need to actually know what they are. And it's a pretty straightforward concept. So, what is a residual specifically? So, I'm under the very first flap. A residual is the vertical distance from the point and the line of best fit. So, in other words, remember we have our scatter plot and then we have the line of best fit going through it. The residuals are is the distance from the scatter plot point to our line of best fit. So, for example, if I was looking at this scatter plot right here, and the points are really hard to see, so I'm just going to go over them with my pen. They're a little bit easier to see on your paper, but on here it's a little harder. But here's all the points. And then the line of best fit is right here. So that's the line of best fit. Now, it asked us to find the approximate residual of the point 37. So in other words, I'm going to find the red dot that says that's at the plot 37. And I'm going to see about how far away it is from our line of regression. All right. So here's 0. I'm going to go over 3 and then up 7. So right here, I'm looking at this point specifically. Now, if you're looking from this point to the line, how far away do you think that is? Like, just think about it. So, like, is it like a unit, unit and a half, 2 units? What do you think? How far away do you think it is from that line vertically? So, what do you guys think? How far away is it from the line just vertically? You can count it. Yep. Guys, you're looking here. You're going from the dot to this line. This is 1 unit, and then we got a little extra. So, what would you say it was? 1.5. All right. So, we're saying the residual is 1.5. So we're going to say our residual is equal to about 1.5 or 1.5. Now, our residual is positive because it's above the line. So if it's above the line, it's positive. Now, on the other hand, so number 2 asks, what's the approximate residual for the point 42? So again, I'm just going to draw the dots very quickly. Again, just so you guys can see them, at least on the board. All right, so there's all the points on the scatter plot, and here's the regression line. So I'm finding the point, or the red dot, that's 4, 2. So I'm going to go over 4 and then up 2. So this point right here. Now, how far away is that point from the line? How many units does it look like it is? 1. Now, let me ask you this. Do you think that it's going to be a positive 1 or a negative 1? Negative. Why do you think? It's below the line. So residuals can be positive and negative. However, it has to be above the line is positive, below the line it's negative. All right. So our residual in this case is equal to -1. So again, below the line, if the point's below the line, that means it's negative. But if we look at the first one, if it's above the line, that means it's positive. And we'll show why that is in a second. Now, last one. So we're finding the approximate residual of 9 and 8. So 9, 8. So I'm going to redraw my points real quick. Again, you guys should probably be able to see them pretty well on your journal, but just for looking at the board's sake. And I'm going to draw the line. And since one of them goes through the point, I'm going to redraw on top. All right. So 9, 8 is right here. What do you think the residual is here? If it's on the line. 0. Why? That's part of it, but is there really a distance there if it's on the line? Because remember, residual is the distance from the scatter plot point to the line. So in other words, do you think it would work that way? No. So if there's no distance, the residual is actually 0. So in other words, if the point is on the line, your residual is automatically 0. So above the line, it is positive. Below the line, negative. And then below the, and then if it's on the line, it's 0. Now, yes, quickly. Now, if we wanted to find it by hand, here's the formula. You would do the y value of the point minus the y value of the line. All right, and that should give you your residual. So that equals your residual. And by the way, the y values of the point and line, they should both have the same x value. So the point has the same x value as the line. The y values are the only thing that's different, we hope. Otherwise, it's just 0. So y value of the point minus the y value of the line, but they have to have the same x value. That's the formula right here. So you might want to highlight it because that's like the how to do it by hand. All right. Now let's look at what residual plots are actually for. All right. So we calculated the residual. All right. Now when we calculate the residual, that was just using the scatter plot and the regression line. Now we're going to actually plot the residuals. These are called residual plots. So look at the next flap. So what is a residual plot? So essentially what a residual plot is that it's a graph that shows the residuals on a vertical axis and the independent variable on the horizontal axis. So in other words, you would have the same x value of the point as the scatter plot point. But the y value would equal the residual. All right. So you would use the x value from your scatter plot point, your original scatter plot point, and the y value would be the residual. Put the phones up. Now, what we learn from residual plots, they're come in handy a lot when we're talking about whether a linear regression is a strong fit or not. So a residual plot can show us whether it's a strong fit or not. And the way we can tell depends on how close to the x-axis it is. All right? How together all the points are. So a strong linear fit is the distribution of the residuals around the x-axis is random and tight. So like there's no obvious line, like there's no straight line, there's no really any pattern to it. So guys, remember last week when I talked about correlation with like the football, the hot dog, and the cookie? You guys remember that? Yes, no, maybe? So to review, if I had a scatter plot, so if I had a scatter plot, all right, and I had a reflection line go through it, and I drew this around the points. It was a football. What type of correlation is it? Strong, weak, or none? Weak. If I had a scatter plot, all right, drew a line through it, and I had a thin circle around it. It was a hot dog. Strong, weak, or none? Strong. And then the cookie meant none. All right. So very similar with residual plots. All right. The closer it is, the tighter it is to the x-axis, the more likely it's going to have a strong linear fit. That's how well it fits. So for example, this one here, here's all of our residuals. All right. And here's the x-axis. So this represents a strong fit because you guys see how tight it is around the x-axis. They're all probably within like a unit or two from the x-axis on either side. So it's distributed fairly evenly. There's about 4 up top, 4 on the bottom. All right. It's distributed evenly. It's pretty close to that x-axis, so that gives us a strong fit. Whereas if we have a weak linear fit, that means the distribution of the residuals around the x-axis are random, but they're loose. So there's no clear pattern, but they're not very close to the x-axis. So here's all my points on the residual plot. All right. Here's the x-axis, just for reference. Do you guys see how, like, if I drew a circle around them, it would be a pretty big circle. It's not like a very tight oval. We get more of a circle. That means we have more of a weaker fit for a linear function. So a linear function would work, but it's probably not the best fit. All right. It's just a very weak version of a linear function. If you also look, the points are highly spread out. Like some of them are up to 5 units away from the x-axis. They're not very close to it. And then lastly, a nonlinear fit, meaning it probably won't fit a linear function at all well. So in other words, the residuals are around the x-axis, but they're not random. And by not random, what I mean is you can easily connect the dots. All right. So you connect the dots and it can draw like a nice line like we would on a graph. So look at this one. Here's all the points. But they're clearly not random. What does that look like to you? What function does that look like that we've discussed a lot in this class? It looks like a quadratic, right? So what I mean by that is if we drew a line between these points, we can easily draw a curve or a line. It's not random. That's what I mean by not random. We can easily, there's a clear pattern. All right. Whereas the ones up top, there was no rhyme or reason to where they were placed. So a nonlinear fit, all that means is another function type may fit better. Now, a residual plot cannot tell us what type of function that is. So even though that looks like a quadratic, that doesn't mean a quadratic is the best fit. So the residual plot cannot tell you what other function fits better. That's when you have to use like your R value and your R squared. All right, so it cannot tell you guys, heads up, come on. It cannot tell you what fits better, but it can tell you that a linear function is probably not the best fit. All right, last thing we're going to do with residuals is actually find the residuals on our own, like the exact residuals, and make them. All right, so the line of best fit for the scatter plot is below. All right. Now, this is the regression line that they came up with. So this fits this line right here. All right, so this is the regression equation. They put it in their, they put the scatter points in their calculator. They found the regression. All right, that's the equation for it that they got. All right, and here are all the original points. So our goal is, because these residuals are not obvious what the distance is, our goal is to calculate all of the residuals by hand. All right. So to help you guys out, what you would do first is make a table like this. This is probably the easiest way to do this if they ever ask you to calculate a residual by hand, especially if they ask you to calculate all the residuals. Now, I most likely won't make you calculate all the residuals. I'll mainly just have you find one, but just so you have practice for it. So what you would do is you would look at the x values, all right? And you would find the actual y value from that x value. So for example, when x is 1, the actual y value would be this point right here, which is a y value of what? What's this y value right here? What is it? 2. So that means the actual is 2. All right, and you would keep going down and doing that. So when x is 2, y is 3. When x is 4, or actually, no, there's another one where x is 3. Now, what am I doing? When x is 3, there are 2 points at 3. So there's 2. There's a y value of 2 and a y value of 5. When x is 4, it has a y value of 4. X is 5, it's 6. X is 6, it's 5. 7, it's this. So 6, there are 2 points for it has a y value of 5 and a y value of 7. For 7, it's also a y value of 7. There's 2 points at 8. One of them is 6. The other one is 8. And at 9, it has a y value of 8. So I just gave you the points, but essentially all you were doing is looking at when the x value is 1, when the x value is 2, 3, 4, 5. You just go down the line on the x-axis, and you're finding its corresponding y value or values. Remember, with scatter plots, you may have more than 1 point under the same x. Like, so at 3, they had 2 points. At 8, they had 2 points. All right, you have to list them all. Now, that's our actual. So our actual comes from the scatter plot. Our predicted comes from the regression equation. So there's 2 ways to do this. If you were asked to calculate it by hand, so you're predicted from your regression equation, we want the exact y values of the point. We're going to do, one way to do it is to plug in our x value in for the x and put our calculator and solve. So for example, we could do 0.74 times 1 plus 1.4. And that would equal, if we put it in our calculator exactly as I put that in, that would equal around 2.14. Now, that can be very, very time consuming. All right. Another way we could do that is put this regression equation into Desmos and make a table of values. Put the phone up. I'm not going to ask you again. All right. So if I'm in Desmos, so this is where you're going to look in Desmos. We're going to plot our regression equation as just an equation. So I'm just going to type in y equals 0.74x plus 1.4. All right. Now, who remembers how to create a table of values? So I want to get actual points from this graph, but I want to represent it as a table. Anyone remember how to do it? So to recap, you would hit the gear key first. So the one where I have that says edit list if I hover over it. So the gear key in the top right corner. Then, do you see where you have this little table icon? Once you click that, you would create a table, and there you have your, it gives you your x values and its corresponding y values over here. Now, if you notice, when we had an x value of 1, we had a y value of 2.4. Guys, heads up. Come on. Heads up, or you'll be standing up. If your neighbor's asleep, wake them up. All right. So when I have a x value of 2, what's my y value? Guys, you're just reading it. What is it? 2.88. So when I have an x value of 2, my actual is 2.88. All right. Now remember, in Desmos, what's nice about it is that you can type in more y values. So for 3, we would get 3.62. And we would put that in for both points that have an x value of 3. All right. So put it in your calculator. Tell me what you get for 4. So if you put 4 into the table for the x, what's your corresponding y value? 4.36. Good. What about 5? So what'd you guys get for 5? Come on. 5.1. What about 6? So someone besides Kyrie, come on. You guys should all be doing this. 5.84. Good. And we'll put that in for both 6s. What about 7? 6.58. What about for 8? 7.32. And put that in for both 8s. What about 9? 8.06. All right. Now, we can then calculate our residual doing this equation, this formula. And the formula is we do actual minus predicted. So we take whatever y value we have as our actual, we subtract it from the y value that is our predicted, and that gives us the residual. That's basically the exact same equation that I gave you earlier. It's just stated differently. So actual minus predicted equals the residual. So you may want to grab a TI for this, or you can use Desmos, however you want to do it. So if I do the actual minus residual, that means I'm going to do 2 minus 2.14. So I did the actual minus the residual, and that will give me, what do you think? Negative 0.14. So this right here is my residual. All right. And you're just going to do that for all of them. So if you do 3 minus 2.88, what's your residual? It's 0.12. Good. If you do 2 minus 3.62. So in other words, guys, you're just subtracting the actual from the predicted. And you would get what? Negative 1.62. All right. 5 minus 3.62. Someone besides Olivia needs to give me an answer. If you have not talked today, you need to speak up. 1.38. Good. Then if we did 4 minus 4.36, what would we get? Negative 0.36. 6 minus 5.1, what would we get? 0.9. 5 minus 5.84, what would you get? Negative 0.84. 7 minus 5.84 would give you what? $1.16. Now, to save some time, I'll give you the last 4. So 7 minus 6.58 is 0.42. It's not negative. All right. And then 6, and then 6 minus 7.32 is equal to negative 1.32. 8 minus 7.32 is 0.68. And 8 minus 8.6 is equal to negative 0.06. So just like that, we calculated all of our residuals. Now, to plot them on the graph below, we take the original y value and the residual, and that's our point. So in other words, this would be the point 1, negative 0.14. All right. So if I come down here to graph, it doesn't have to be perfect. You just want to kind of get close. All right. Here's your y-axis. Here's your x-axis. So it's actually in the middle. So if I graph my residuals, I would have 1 and then negative 0.14, which is about right here. 2 and 0.12, which is very close to the x-axis, about right there. 3 and negative 1.62, so it's about a little more than halfway below negative 1.5, so right there. 3 and 1.38, so it's a little bit less than 1.5. 4 and negative 0.36, so it's a little bit lower than the one that we had at x equals to 1. 5 and 0.9, so very, very close to hitting 1. 6 and negative 0.8, so again, very close to hitting negative 1. And 6 and 1.16, so a little bit above 1. 7 and 0.42, so that'll be about right here. 8 and negative 1.32, so a little bit past 1. And then 8 and 0.68, so a little bit past halfway. And then 9 and negative 0.6, so that's like almost on the line. And this is what your residual plot would look like. Now, looking at this residual plot, first off, will a linear function fit this the best? Is it fairly random? Like you can't just draw a nice line through it. It doesn't look like a zigzag. What do you guys think? So would a linear function be the best fit here? Yes, no, maybe. Yes. All right. What about how strong of a linear fit do you think this is? So is it fairly tight around the x-axis, or is it pretty loose? It's pretty tight. So this would be a what type of linear fit? It would be a strong linear fit. So this would be a strong linear fit. All right. Now, there's one more thing I want to show you, and that's just Desmos will also graph a residual plot for you, and I'll show you how. All right, so you don't need to do this if you don't want to, but I'm going to do it. All right. So I'm going to first type in my scatter plot from this example. All right, so I'm going to do add table, then I'm going to do 1, 2, 2. No, that's 3. 3, 3, 4, 5, 6, 6, 7, 8, 8, and 9. And then I'm going to type in the actuals that we had. So 2, 3, 2, 5, 4, 6, 5, 7, 7, 6, 8, and 8. All right. Now, who remembers what I type in to get a linear regression? What do I type in to activate the linear regression? So, review from last week. What do I type in? Guys, what's the standard form for a linear equation? With a slope-intercept form, what is it? Y equals mx plus b. So guess what? You'll do y1, so we know we're using the table, little squiggle, ax1 plus b. Now, once you get the regression, it's very, very easy to get the residuals. Do you see right here in our regression stats how it says residuals right here and then a button below it that says plot? Do you guys see that? If you click it, this right here is your residual. So the purple dots right here, those are your residuals. And judging by it, it's pretty close to all of it, so it would be a fairly tight fit. All right. So again, if you need to see a residual plot, but you don't have time to plot one, that's another way you could do it. Once you get the regression, it should plot the residuals for you. All right. Any questions on that? All right. So that's it for notes today.